class is to really kind of go over the concepts that we covered last week again and kind of give you guys a quick review. And then following that, we need to move forward and start dealing with this new idea of conditionals. So in programming, there's some fundamental notions that you have to get, and conditionals is really kind of one of those major big items. Expressions are kind of the introduction. You know, you start dealing with variables, you start dealing with assignment of values to those variables and manipulation of those values. But once we get to this idea of conditionals, this is where we start to be able to divide and make choices within the scope of a program. So this is, again, it's very essential, it's very critical for you guys to kind of get this notion. So just so we're clear, last week we covered these expressions. Does anyone have any questions concerning the assignment from last week?
Yes.
Yes, Tamika, how can I help you?
The only thing I'm having a problem with is just basically putting everything together.
Okay, and when you say putting everything together, can you be a little more descriptive of that?
Like the dog years, I know that dogs age 7 times faster than a human. Now, like when they give us our givens, do we have to like pick our own human age or?
No. Okay, so basically what this is saying is that if I'm going to type in the age of a dog, like I have a dog and his name's Apollo and he is about 7 years old. So how old is he in human years if we assume that for every year that I age, every time that, or the the Earth spins around the sun, he ages 7 years. So if he is currently 7 years old, how old is he in human years? Well, the equivalent would be what? 7 times 7, right? 49.
Yeah, 49.
Right. So you can do that math in your head fairly easily. So I'm just going to go here, and we're going to write this. We're going to go over this problem. So what we know and what we've been given is that dogs age at a rate of 7 times that of a human. Okay, so that's what we know. Well, if we know that fact, that means that we're probably going to be given either a certain number of dog years or a certain number of human years, and we need to convert them. The same way that you would convert from Fahrenheit to centigrade in science class. Remember, I don't know if any of you guys took chemistry, or any of the other sciences where you had to do temperature. But you would have to, if you wanted to convert from one to the other, there was a formula you would use to do that conversion. Well, that's basically what we're doing here. So what we have is we're going to have two variables to start with. So we're going to say the first variable is going to be dog years. All right. And we don't need to set that equal to anything at the moment. The second variable we need to do is human years. All right. So now we have these two variables. So now let's begin to kind of talk about what the relationship is. So the relationship is, so for every human, there are 7 dog years. So what does that mean? That means that when we set the value for dog years, we want, or the value for human years, we want to know how many dog years that is. So we can say that, well, dog years is going to be equal to human years times 7, right? But we haven't set the values. So let's just start out setting a basic set of values. So dog years in this case is going to be, let's say, 0. And in this case, we want to set human years because how old is my dog? He's 7. So, right, so he is 7. He is 7 human years old. How old is he going to be in dog years? Well, it is the number of human years times 7. And then what do we do to get that out? We do a console.log. And the value that we want to put in there is dog years. So let's take it and take a look at this and test it. 49. Do you follow that now? So let's
Yeah.
take a, okay. So instead of saying a set value for how many human years, let's just add a prompt. Okay. So let's think about what's happening here. So the computer starts running this program. And what it does is it starts at the beginning and it says, I need a place to store some information. I need a variable. And the name of that variable I'm going to store is called dog years. And just to start, I'm going to make that equal to 0, saying that that is the number 0 and that's what it's going to hold for the time being. The next thing that we need to do is then we're going to say, hey, well, we need to store not only the number of dog years, but the number of human years. So we're going to create a little place to hold that. And then from there, that is just a little box to hold that information. And we're going to push that information in there. Then, so do you get that part?
Yeah, I understand that part.
Okay.
Like the part where it says, I kind of understand it a little better when he says how many years old is your dog, but I'm trying to figure out why is that in the human years part, on the human years line.
Well, okay, because the relationship that we're trying to say is, all right, I told you that your dog ages 7 times as fast as you do, right? I see your
Yep.
dog's 5. How old is your dog in dog years?
2.
Oh, if I say he's 5 human years
Oh,
and
in
he's
dog years. In dog years, she is seven and a half.
okay. So your actual. I said if you had a dog that was 5 years old.
Oh, I'm sorry.
Yeah, because I can't. I don't know if your dog is actually 2, so I don't
She
know.
is. She's seven and a half, but she's closer to 2. That's why I said that. She's 2 years old.
Okay, so
But
if she's 2 years old, then how old would she be in dog years? She'd be
14.
right. Okay, so you can do that math, right?
Yeah.
So in your head. So now we just got to kind of write down how that works. So I said how many years how old is your dog in human years? You'd say 2, right?
Right.
Well, that's the same thing that's happening here. We're just storing that information. Well, then once we store that information in here, so right there, that's what we're saying. Is we're just storing that information, and then we're multiplying that information, whatever it is, if it's 2 years, 5 years, 1.5 years, doesn't matter.
I
We
got
then
it.
store that, multiply that by 7, and this in line 19, and store that into the variable dog years.
I got it.
Okay.
I was lost because when it was
This,
dog years and human years, I'm sitting there adding in my age. Like I didn't get it. So I was
yeah,
going off
but do
how
you get
old
it?
I was and how old the dog was, and I couldn't. But now that you're
Right.
actually hearing you say it, I'm like, duh, that's how old she would be in human years.
Yes. Right. So that's the basic nut. Does anyone else have any questions concerning this? Oh, and Ellie Marie, hello. I see you said hello. Um, okay, all good. Okay, I'm gonna take that as a whole bunch of all goods.
Oh,
All right,
yeah.
so perfect. So what I'm going to do now is I'm going to move on to this idea of conditionals. Now, conditionals can take you anywhere from we can do this in probably 30 minutes if everybody catches on, or we can take a long time. So I don't know how long this is going to be. So we might be a short class. It might not. We'll see how it goes. But let's talk about this idea. So if I told you that you had a choice between your favorite dinner and your least favorite dinner tonight. Okay. So if I told you had a choice between your favorite thing you ever want to eat and your least favorite thing, obviously you could easily make a decision, right? Well, computers work kind of the same way in the sense that it's easy for them to make a decision because we have to set the world up So that way they don't have any ambiguity or any unlikely or any possibility of not getting the right answer. You guys understand that? They have to be able to discern between one thing and another. They have to be able to select. Anybody getting this idea? Did I lose anybody? I'm getting the responses. Did I lose anybody actually on?
Oh no, I'm here. I hear you.
Oh, okay, there we go. I'm sorry. All right, thanks, guys. So if you can get this idea, the way we do this is we do this with conditionals. So the basic conditional is the if. So basically what if does is it allows us to say, if this thing, this part is here, let me make this a comment right here. So basic conditionals, if. So the if syntax works like this. You have the if, and it's presented like that, and then in the middle part, this thing, this is evaluated. You put the curly braces in, and then in that section, if the evaluated is true, then this will execute.
Is this like if and else?
This is an if and else. This is an if, so this is just the most basic version.
Okay.
EXE, oh, see, there it is, okay. But, BALUA, that doesn't matter. So let's write one real quick. So we're going to create a variable called a test value. And this is a lame name, and this is going to be equal to, let's say, 10. Then what we're going to do is then we're going to create an if condition. If test value is equal to 11, sorry, here's another nut. It's 2 equals. You have to remember that. That's important. That's critical. The code will look and act all kinds of weird if you don't do this right. If you don't remember the 2 equals, you'll be debugging it forever because you can't figure out why it doesn't run. 2 equals is an evaluation to see if things are the same. 1 equals is assign something from the right into the thing on the left. So that basically, you see how in this line 19, you see what we have there? There's an equals. That is, we're basically pushing data into the value of test value. On line 21, we're evaluating test value against the number 11. It's a very critical thing. I want you guys to pay very close attention to that idea. So if test value is equal to 11, then we're going to do something like, let's do, actually, we're going to create a new variable called result. Okay. And we're just going to make it empty. So we're going to make an empty value. So if variable, or if test value equals 11, then result value is going to be, so we're going to set that equal to something. So we're going to set that equal to a string, and that string will say, this is true. Okay, so then what we're going to do is we're going to console log the result value. So okay, so what I just did, I'm going to set on line 20, I'm going to create this variable called result value. Inside of that, I'm going to put this string, or this basic little piece of text, we're going to put in there, and it's going to say initial value. The reason I'm putting that in there is so that way, if nothing happens, we know that there's nothing happening because we see that this response has come up. Does anyone follow why I'm doing this? Yes,
What do you
excellent.
mean?
Thank you, Matt. Okay, so let's just start from the top. We have two variables. The variable named test value that we're going to test against. We're going to check the condition of. We're going to have a result value, which is basically just a way to hold answer data. And then we're going to perform our conditional evaluation. And in that, we're going to have the test value. We're going to test to see if it's equal to 11. If it is equal to 11, we're going to change the value of result value to this string right here. Okay? And then we're just going to log out the result value. So let's take a look at it. Okay. So if we look down here in the console log, we all see what comes up. It's the initial value again, right? So it's the same value that we had before that we initially set. So in this case right here. So now if we change and evaluate instead of against 10 or against 11, we go against the number 10. This value right here is 10 because we set it, and that we test against it, we check to see if it's equal to 10. Now the answer came back different, right? Does everyone follow that? I'm going to need a couple of actual affirmations and some yeses, please.
Yes.
Thank you. Okay. This is why I made sure to ask, because this is critical. All right. Stephen, so real quick, do you understand this portion right here? This is line 19 and 20. So we pull up some initial values, and we set the values. We create some variables, and then on line 26, you recognize, okay, so you got this last part here too, the console log portion, right? Good. All right. So then this is the part that's the trick. All right. I'll break this down a little bit so that way it's a little easier to read. So what is the value currently for the variable test value equal to?
10.
Right. Okay. So if this thing right here, if I asked you, is test value equal to 10, which is what this says in code, what would the answer be? True, right? Excellent. So if this portion is evaluated, which is what we're doing, and it's true, then we're going to make it equal to this. That's all it's doing. We're just saying, if this part right here in between these parentheses is true, then do this. You get that idea now? Perfect. All right. So again, we're going to make a quick change here. So now we're going to set the initial test value equal to 1, which is not going to be equal to 10, right? So this is going to evaluate to false on line 23, and it stays the initial value. So does everyone kind of get this concept? Again, these will become more complex later on, but for right now, this is a very simplified version. So we're going to extend, we'll extend this a little bit. We're going to create something called else. We're going to use another condition called else. So else doesn't have any additional conditions because it's tied to this guy right here. So on line 23, we have the if condition, right? So if that's true, then it does the first bit of code inside of this set of braces. Else, in other words, if this is not true, then I'm going to do this. So in this case, I'm just going to copy the code because it's nice and easy. Somehow or another, I lost my parenthesis. All right, and so now it's going to be equal to false. So just so we're clear what happens here. We started, we created two variables. We assigned a 1 to the test value. We go down here, we are evaluating it against this number that we have here, which is 10. So if the test value is equal to 10, then it will be this, will be the result, in result value, this section here. Otherwise, the other value will occur. So in this case, we should expect to get the the false value. So this is false. Everyone follow along? Ooh, excuse me. Good. Okay. Ooh, I have another one coming. I apologize. Okay, so, well, what happens? Okay, this basically splits the possible answers into one of two possible answers, right? So on one hand, you have it's true, and you do this. On the other hand, it's false, and then so you have to do this other thing, right? So there's no way to make like a third option with the tools we have right now. Everyone follow that notion? Good. So we need to, let's create a way to, or talk about a way to add a third option in here. So between the if and the else, we can do an else, if, and repeat the same process. Test value, evaluate that against this particular value, and then do some code. Okay. So I'm going to change these just so that way we know exactly what's going on. Don't you lose the original variable stated before? Do you
My
mean
question
the
is
initial
just,
value?
yes. So does that go away based upon the results of the test values?
Yes. Yes.
Okay.
So what I did is I initialized the variable, and I initialized it with the purposes knowing that I had to write an if statement that had basically it was an if statement that wasn't going to have 100% of it. It's not going to fire 100% of the time, right? So there are times you're going to write code where you're only going to need something to happen if this other thing is true, right? You don't need to like have a system where, or you don't need to have like an answer where you're always going to do this thing, or you're always going to have to make a choice. You may just simply have to make a choice, you know, in the positive. You know, hey, if this stuff is right, then do this other thing. Like, for example, you know, if it's the end of the semester, calculate all the grades, right? You don't need to calculate the grades every time you check or do anything. You do it towards the end. You have to wait until that condition is true, and then you fire off those events. But you, again, you don't need to write a whole bunch of stuff to not check stuff, if you know what I'm saying. Does everyone follow that kind of an example? Yes. Good. Excellent. Now, let's see here. Okay. No, Jessica? All right. Let me see. And check. All right. So now we have this if, we have if else, and we have the else condition. Those are basically the three common things we have to do. I mean, that's kind of it. There's a simplified version of just the if. It's called the ternary, T-E-R-N-A-R-Y, I believe. Is it right? Yeah, it's up there at the top. Okay. So this is basically like a shortcut version of an if, and in the homework they're going to ask you to do it, and here's the syntax. So the syntax is the condition to be checked, then you put a question mark, and the stuff to be done, a colon, and the else condition, stuff to be done. Okay, so basically what does this mean? So let's write one real fast. test value is equal to 1. Okay, so what is this basically doing? So basically we're taking the same test value we have from the top up here, which is equal to 1, and we're taking it, and we're writing this little conditional, the same thing that we would have up here in this if, right here on line 23, looks exactly the same. Except you just put it in parentheses, you follow it with a question mark, then you put in a set of parentheses and put whatever it is you want done, then you put a colon, and then you basically put the else condition otherwise. So let's try running it and make sure that it works. If else is true. So wait, hold on. Oh, sorry, ternary true. There it is. Yeah. All right, so does everyone kind of follow that? This is syntax. If you just remember, again, this is in the homework, so you're going to need to write at least one of these. So the syntax is available if you just Google it. If you Google this term right here and JavaScript, there's plenty of examples for how to do it. What was that? I heard somebody yelling.
Sorry.
Oh, okay, cool. No, it's a mic problem, no problem. All right, so anyway, it's pretty basic. The syntax is a little confusing, a little hard to read. I personally don't like them because they're hard to read, but they're in the homework, so I would suggest you guys do them. I think they're worth, I want to say they're worth like 3 or 4 points on the overall grade for this assignment. So just keep that in mind. Let's see. Actually, I can tell you right now. Ternary. So it's 35%, so it's worth a fair amount. So just keep that in mind. Let's see. Next item, forbids. Okay, so now the idea of not equals conditionals. So when we do checks against stuff, right? We can say not only is something equal to something, but we could also say, is it bigger? Is it smaller? Is it bigger and equal? Is it smaller and equal? Or is it something not equal to? I mean, these are all possible answers that we could be interested in looking for. So the way we employ those is much the same way we have them employed above here. So I'm just going to go, I'm going to copy this code right here, just so that way we have an old version, and comment all of this out. So that way we have the old version, so you have that for record, and I'll post all this stuff up to the GitHub. And then then we'll just kind of play with it. So if it is less than or equal, so if we're looking at line 46 here, we have the same if condition that we had from before. So at this point, we simply said, is the test value less than or equal to 10? So again, if the test value is equal to 1, this would be true, and it will fire this portion, set our result to the if is true, and then it will plug in the result. Everyone follow that? Good. I like yeses. Those are my favorites. All right, so then we have this idea, this not. Okay, so the exclamation point, then followed by the equals, is not true. So if this is evaluated as false, then it returns true. So let me rephrase that. If these things are not equal, then it evaluates to true. I'm thinking of the not function. So basically, if this does not equal that, in this case it doesn't, it would be evaluated as true, and then this portion of the code would fire. We have.
So it's the opposite?
Is it not true? So I can ask it this way. Is test value not equal to 10? Well, test value is equal to 1, right?
Right.
So is 1 equal to 10?
No.
So, okay, so there you go. 1 is not equal to 10, so that's true.
So, okay, I think I get it. So, the test value equals 1. The result value is the initial value, but the initial value is 1. And then the test value is 10. Result value.
Test value is not 10. No, test value is never 10. Test value is only 1. And it's asking, hey, is 1 not equal to 10? The answer to that is yes, it's not equal to 10, right? 1 and 10 are not the same thing.
Right. But I'm kind of lost because it's like...
Here we go. Let me ask you that. Okay, you know how to do this, right?
Yeah.
Okay. If I said, okay, so at this point you know that test value is 1 and the other one is 10. And the evaluation is 10. So if I asked you in this condition, all I'm asking you is test value, is the value of test value equal to 10?
Is the test value equal to 10?
I'm sorry, is it not equal to 10? Is it different than 10? Is 1 different than 10?
Yes.
Then it's true. Then yes, then that is evaluated. It is not equal.
Where I'm getting confused is because I see 2 test values.
What do you mean?
I see the test value. That's the one I'm looking at. And then I'm looking at
that's
that
what's set
right there.
Okay, that is okay. So it's being set.
Okay, that's the variable. I didn't see. Okay, that's the variable. So that's the value that you've assigned it to. Okay.
Right.
All right.
You following along now?
Yes.
Okay. So we have that. So then, obviously, we didn't. So is test value greater than or equal to? It's the same thing. Right. This would
less than.
If is test value greater than or equal to 10? If that is true, then again, it's another form of condition that we can check against, and that basically is the nut of it. So we're going to take this and we're going to go to the next piece, the idea of ands and ors. Again, we're going to copy this, comment it out, and I'm just going to slide and cut off some of the stuff here to kind of simplify. We're going to create a new variable in this case. It's going to be test value 2, and that's going to be equal to 100. I'm going to get rid of this section, and we're going to change the code a little bit, just so that way we have it a little cleaner in the console log section. So all I'm doing is moving the console log from the bottom into the... Steven, the answer to that question is yes, you go there to command slash. Good one. So we're just going to move everything in there. So basically this is going to be not thank you, sorry.
Oh my gosh.
Okay, so hey Tamika, can you mute your phone? Thank you. So what do we have here? So we have the test value is going to be greater than or equal to 10 currently. But we want to check to make sure there are other possible conditions that we might want to meet. So let's say we wanted to know also, let me write it down so that way we're clear what we want to do here. So we want to check to see if our test value is, let's say, equal to 10. I'll do less than or equal to 10, and test value 2 is greater than or equal to 50. Okay, so now we have two conditions here, right? So we have this possible condition that is that we need to basically be able to check for both values. So luckily we have a tool that lets us do that, and that is the and, which is this, and then there's the or, which is this. Okay, so those are the pipes, and if you look at the return key on the far right-hand side of your keyboard, above that, they're directly above it on the far edge, is a backslash. And so that guy right there, if you hit shift and hit that, that's the pipe. So one is and, the other is or. So what we're going to do here is we're going to say, what are we testing against? We want to know it is test value less than or equal to 10. So we need to make that be the case. And is test value 2, what did I say? Less than or equal to 50. Okay, so let's run it and find out. No, it's not true. Why is that? Because this guy right here is 100. Let's run it again. We changed it to 10. There we go. So do you guys follow along with what's going on here? Good. I like it when people are following. Okay, so we're going to test value is equal to true for and. Okay, so we can do the same thing with or. Except this time, what we're going to do here is we are now going to turn this back into 100. So now we know the test value 2 is going to be greater than 50, right? Everyone follow that? So the first one, the and should come back with nothing, but the second one, the or, should come back true, because the first condition is, there we go. So, right, so in this case, what's happening? The or value, because the first portion is evaluated as true, or the second portion is evaluated as true, then the whole thing becomes true. That's what or does. Same thing happens here with and. So the first piece that I have highlighted on line 73 has to be true, and the second piece has to be true in order for the whole thing to be true. Everybody get this notion? Seeing a few yeses? Good. All right, that basically covers all the stuff we need to cover today, I believe. We check the syllabi, or the hard-coded. Again, make sure you guys read this, because this assignment is worth quite a few points, and it is critical that you all notice this section over here on the far right, this poor section. Be sure to take note of that, because it is a devastating impact on your grade. It can be devastating. So let me pull this back up. All right, does anyone have any questions about the general topics that I've covered today? All right. If anybody here has no questions, you guys are welcome to go. I'll hang out here for a few more minutes, and just to make sure everyone is doesn't have any lingering questions or doubts. Practice soon, man. The faster you get to this, the easier it'll be.
I know I do. I'm just waiting on everybody to leave because I don't want to hold people up.
No, they can go. I mean, I'm just saying. I will do an example. Yes. First problem in the assignment. In the assignment or in the worksheet. And no, ask the questions, because if you don't ask, then they're not gonna. Some other people might not ask, and I'd rather have them learning. I mean, it's their time, so maybe you'll spark some knowledge that they wouldn't have gotten otherwise. So.
Well, no, because mine is not on conditionals. I think I pretty much kind of understand conditionals because I understand the if and the else. I just kind of, the only thing with the if and the else in the true part, the true and false, is, to me, it seems like it's just the opposite of saying yes or no, because I know if someone asks me a question, say like, is the sky blue? And I'm like, yes, the sky is blue. That's how I'm gonna answer. But it seems kind of backwards with coding.
Here's this. Okay, if it's a sunny day, I'm going to go to the beach. Okay, that is logically kind of the same thing, right? It's the notion of you deciding the condition under which you're going to go to the beach, and then go to the beach in accordance, right? That follows that same line of logic.
Right.
So it sounds to me like you may have there may be some you may be having a difficult time with that kind of process of converting from physical reality in the way you normally think into this way of programming, and really, I call it it's often called like an epiphany, a moment of clarity, or something like that, where all of a sudden you're going to work at it and work at it and work at it and work at it and just think it's impossible, and then one day you're just going to be like, oh, I get it.
Yeah, because
so,
I'm at that. I think it's impossible right now.
Yes, I've been there. Believe me. 3 o'clock in the morning.
I quit. I can't get it. I don't understand it. But
if you want it, you got to work it. Start going back over those basic problems, and again, you and I can pull that aside, and because this is like I think you're gonna need some coaching in technique for kind of how to tear problems apart.
Yeah.
So I think we should pull that off. So Ellie Marie, I'm going to a Fahrenheit converter. Can someone pull up the math for that so I don't have to go hunting for it? Stephen, was that you saying you would find the math for me? Okay, so if we're going to talk about the idea of a Fahrenheit converter, what are we really talking about? I mean, we're really we're talking about 2 possible options, right? Where you're going to need to either pull in data as Fahrenheit or pull in data as Celsius. Okay, so there we go. That's the part I need. Thank you very much. Oh, that doesn't look happy. Okay, so you're either going to need to pull in the information in terms of Fahrenheit or terms of Celsius. So it's really, you guys should be able to write a converter. I mean, it's basically the dog ears problem all over again, where you convert from one to the other. So, and then just simply return the value that you're interested in. So how would we do that? There is, let's see, 212 Fahrenheit is 100. Is it 100? Result temperature. 0 Celsius. 100 Celsius is 12 and 12. Fahrenheit is 30. Right. Okay. So there's an actual there's a better representation, but I'm gonna simplify the problem. Right now, there's actually, I don't remember where the math is, and I don't want to go hunting for it, but we're just going to do a simplified version that assumes that the scales are equal, so that for every 1 degree in Fahrenheit, or sorry, in Celsius is 2.12 degrees in Fahrenheit. Okay, so I'm just going to put this down. General assumption that the ratio of degrees is equal between and C. Okay, so that means that 100 C is going to be equal to 212 F. Okay. Which means that C, which means from our, remember from algebra that then we could do that in algebraic terms, means that C would be equal to F, right? Everyone follow that? So if that basically all we're doing is we're saying for every 1 degree in Celsius, there's 2.12 degrees in Fahrenheit. That's it. Okay, so now we're going to pull in we're going to kind of put this into terms that we really understand in programming terms, I guess. So we have to do 2 converters, and then we have to also do a switch that selects between the 2 converters. So we're going to create 3 prompts for the user. So variable 1 is, let's call it C or F, Corf. And that's basically going to be a prompt. And that prompt is going to contain some information like C or F. Again, you guys can make it more robust. And this is a Fahrenheit type selection. So it's just selecting which one we want. We have a variable for the incoming value of Fahrenheit. So we're going to call this FER. No, FUR, how do you spell it? FUR. FAH. Chemistry teacher from high school would hate me. All right, and so that we're just going to set that equal to 0 for the time being. We're going to have a variable, and we're going to call this Celsius. We're going to set that equal to 0 for the time being. All right, so now we just have to kind of do the math. So actually, first we'll do the selections. So we need to create an if statement. So if the Corf value is equal to C, then we're going to do this stuff. Else, we're going to do this stuff. All right. What did I just do? Okay. I took the value that's coming in from this prompt, and it's going to either be a C or an F, I assume, from the they are written. That value comes in here, and if that value, I convert it to an uppercase, is equal to this, an uppercase C, then I am converting from Celsius to Fahrenheit. I guess it would make more sense to do it the other way. So this would be Celsius to Fahrenheit. So how do we convert from Celsius to Fahrenheit in our super simplified universe? We say, what's the value? Oh, we're going to need to set this. Here we go. This is going to be a prompt. Actually, ooh, you know what? I have a much better way. Let me clean this up a little bit and talk this through a little more clearly. The temperature. Okay, I initially assumed that we were going to pull in two values of Fahrenheit and use two variables of Fahrenheit and a Celsius value, and then just put the information in there and pass them out. We don't actually have to do this. All we have to do is take in the temperature value and then return the results of the calculations that we perform. Does anyone understand what I mean by that? All right. Okay, so Stephen, I can ask you this way. Can you, if I ask you to calculate Fahrenheit from Celsius, can you do it? If I said it's 100 degrees, what's the temperature in Celsius? What's the temperature in Fahrenheit? You could do that in your head because it's obviously given. I've done it a few times. Okay, so being that being the case, I'm only giving you the temperature, right? The number, and I'm giving you the type. So I'm really giving you two pieces of information when I ask you that. So I don't really have to add a third piece of information, because if I said I give you 100 degrees and I ask you to calculate it 100 degrees Fahrenheit and convert it to Celsius, which is the opposite action, while it may take you a little bit with playing with the computer to get the numbers right, you should be able to calculate the same thing, correct? Yes, good, okay. So we're just doing the same thing here. So we're getting this temperature, and if it is Celsius, if it's coming in as Celsius, what's our ratio? In order to get to Fahrenheit, we take it and we multiply it by 2.12, right? That's our calculation. So we could console log that value out, right? Well, if that's the case, well, we can just copy that down here below, right? And just do the opposite. Does that make sense to everybody? And then we'll start playing with it. So we get some prompts now. So we're going to do Celsius. Actually, we're going to do small just so everyone can see the coolness that is this. We're going to put 100 degrees in there, and it comes back with 212, as we would expect. Okay, so let's try doing it the other way. F, lowercase, keep that in mind. And we're going to do 212 because we want the numbers to work easy. There we go. So again, this system, pretty simple, pretty easy for everybody. You guys follow along what's happening here. We're making some simple choices based on this information. All right, do you guys have any other questions? Okay.
The two uppercase, the dot two uppercase.
Yep.
Does that automatically make the letters uppercase when the user enters them in, or is that just how it's displayed on the output?
That has basically when the program's processing, it does a conversion. So if you want to see it, so we could do this, throw a console.log, the co my corf to uppercase. Okay, so now, just going to put this down at the bottom. This is just a test value, so I'm just going to comment this out. This is just so people can see the test value. So we're going to put in a bunch of stuff in here, all lowercase, and a bunch of stuff all lowercase. And so you see what it does is it converted it all to uppercase.
To uppercase, okay. Okay.
All right. There's a bunch
And
of
that's
string functions.
CONF dot to uppercase.
Well, no, it's just the it's the dot to uppercase that does it. That's the only part that does it. That's the part that matters.
Okay, and then I just wanted to double check the double equal signs. The double equal is the equal sign sets the evaluates the equal sign sets the value, and the double equal it's equal to what the value is set to.
Is evaluating the values, the two different values given. I can give you another version of it. Let's just do it like this. Okay, that's an evaluation. See how there's no code, there's no errors?
Mm-hmm.
Right, so same thing there. So, for example, you see how you're getting errors? Because you can't set the number 10, which is itself a value, to something. You can only evaluate it. All right. If no one else has any questions, I'll have this stuff posted here shortly. And Ellie Marie, if you need any help or anyone else does, please don't hesitate to contact me. I try to be receptive. All right.
Okay, thank you.
Yep, thank you guys.
All right.
All right, bye.
Bye.